Hi guys, this is lesson 210. We are almost to the end of the unit, and it's composition of transformations, but a second day. So we spent lesson 2.9 talking about how to do the transformations ourselves. Today, what we are looking at is the transformations have been done. Can we figure out what composition of transformations have occurred? So here, the first one, we're just going to hop right on in. You have triangles ABC and DEF drawn. And what that says there is triangle ABC is congruent to DEF. So you could almost think of like D as being like A prime and E as being B prime and F as being C prime. All right. So if you think about it like that, so that everything has to match up, it says describe a sequence of rigid motions that maps triangle ABC onto triangle DEF. Now, because it specifies rigid motions, that leaves dilations out, all right? So what's on board is it can be reflection, it can be a translation, and it can be a rotation, but no dilations. All right, at least not for this first one here, all right? There are exceptions to that rule, just FYI. So when it says describe a set of rigid motions that'll do it, you got to think about how can I get A to land over here on D, all right? And then B to land on E and so on. So sometimes you want to think about like the orientation of everything. There's also more than one answer. That is always really important to note here, that there's multiple ways that we could do this. So sometimes you just got to go with a way that you can come up with, right? Something that stands out to me is that the triangle looks essentially like it's upside down. So you might want to think, okay, could I flip it over to get it in the right direction? In this case, yeah, I probably could flip it over, but then I would need to flip it again. So maybe it's a combination of reflections. Another option would be to take this thing and rotate it all the way around, which would be 180 degrees, and then translate it into the right spot. So there's probably a couple of different ways that we could do this particular one. Right? So because a rotation is not always something we're going to be able to get away with, I say let's try this as a rotation. So if I take and I rotate point A, or this whole triangle, excuse me, full 180, because I want it to flip completely upside down. So let's try a rotation of 180 first. Let's look at where that would take point A. So let's use A as our example. So we've got the point -1, 2, 3, up 1, 2, 3. And then if we rotate that 180 degrees, I'm going to spin my paper on you. A is now going to land over here at +3, -3. So let me write that down. It's going to move to, I'll call it A prime, +3, -3. And this is where I definitely want to use my pencil. So I'm going to bite the bullet here. If I go over to 1, 2, 3, down 1, 2, 3, this is where A would land, right? It has to eventually match up to D, but that's in a pretty good spot because if I could just shift it up, that would do it. So shifting it up would be a translation. And so based on this, I would be shifting it up 1, 2, 3, 4, all right? The thing is you have to make sure that works for all the points. So let's double check that. Let's try that with B. So B right now is the point -1, 2, 3, up 1, 2, 3, 4, 5, 6. All right. If we rotate it, B would now be the point 1, 2, 3, -1, 2, 3, 4, 5, 6. So 3, -6. And so it'd land down, let's see, 1, 2, 3, 4, 5, 6. Okay, that would be my little B prime. We're saying if we shift it up 4, it should land on the triangle. So if we shift this up 1, 2, 3, 4, yeah, that's going to be perfect. That's going to land on E. Awesome. So what the heck does that mean? It means I need to do this first and then translate up 4 second. So there's two ways that we can do this. We can write it out or we can write it with notation. Since we just practiced a whole lesson on notation, let's use notation here. But we have to remember, kind of have to write it in reverse. So I would start by writing down triangle ABC. That's what we're going to be moving. I want to, rotate it 180 first. So that would be a rotation of 180 degrees of triangle ABC. Then we would translate it. So then I work backwards. Then it's a translation to make it go up 4. You got to think. X doesn't change, but Y would go up 4. So it'd be 0, 4. That should equal triangle DEF. All right. What if I just said that in words? Well, then write it out. We can say we would rotate 180 degrees followed by a translation of up 4 units. All right, so we'll do a little combination of writing it using notation and then just writing it in words. Now keep in mind, I didn't fully finish point C, but if we finish it out, just to convince you, C is starting back here at negative 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6. So if it starts at negative 7, 6, a rotation of 180 degrees, it would go to positive 7, negative 6. So it would go over to 7, down 6. Here would have been my C prime. And then when we translate it up 4, 1, 2, 3, 4, it'd land exactly where we want. All right. Awesome. All right, let's come on down. So first one's always a little bit to talk through. Second one, maybe it'll go a little bit smoother. So on the set of axes below, triangle ABC is congruent to STU. So that means A needs to go to S, and then B needs to go to T, and then C needs to go to U. Keep in mind that connection there, all right? So right now, point A is the point negative 1, 2, and then up 1, 2, 3, 4, 5. And ultimately, we need to get it to land at S, which is 1, 2, 3, 4, 5, negative 2. All right. So with this, let's see. It kind of looks like we are rotating here. Just 90 degrees. So if we rotated the paper 90 degrees, let's see. A would become the point, negative 5, negative 2. Oops. And I just realized I wrote it wrong here. So negative 5, negative 2 is point S. All right. So it says describe a sequence of rigid motions. I only see one. Now, is there a way that we could get around that? That's a really good question. We could rotate it this way and then reflect through the origin. That seems slightly excessive. Now, I have had students ask me in the past, can we like cheat a little bit? And could we just say afterwards that we do a dilation of 1? I mean, technically, sure. But otherwise, I would look at this as a rotation of 90 degrees. Let's double check and make sure that works for the other points. So B is negative 1, 2, 3, 4, up 2. So negative 4, 2. And then if we rotate that, that would land at negative 2, negative 4. Which is exactly where T is, negative 2, negative 4. All right, so for now, I'm going to say rotation of 90, and then I'm going to cheat, followed by a dilation of 1, because that wouldn't move anything at all, right? So a dilation of 1 is a rigid motion because it doesn't change the size, hence why I'm kind of cheating. But maybe let's come back and we'll chat about this one to see, did you guys think of something different? And also, I'll go check my answer keys and we can talk about it then. All right, let's keep moving. For number 3, let's see, it's saying on the axes, ABC is graphed and triangle QRS is the image of ABC. Given those coordinates, describe a sequence of transformations. All right. So a sequence of transformations, it really does mean you should be able to come up with at least 2 transformations. If you need a third one, that's fine too. All right. So in this case, a couple of things. If we were to simply rotate, so I'm going to turn my paper for a second. If I rotate this, notice how it's vertical and then kind of kicks out to the right here. If I look at the triangle for QRS, you have the vertical and then it kicks out left. So we're probably going to need to possibly rotate and then do a little reflection here. That's the combination that I would think of, right? So let's see if we can rotate this thing. So if we rotate it, I would need to rotate it so that it would be standing up 90 degrees. So let's try that. So if we take triangle or point A, which is -2, -1, B is 3, -1, and C is -2, -4. And let's rotate it 90 degrees. All right. So if I do that, I'm going to turn my paper. You know the drill. I'm going to grab my Post-it over here. So now I've got point A at 1, -2. I've got B at 1, +3. And then I've got C at 1, 2, 3, 4, -2. All right, let me turn my paper back. And I can use all of these. So I'm going to call that, I guess, my A prime here is 1, -2. My B prime would be 1, 3. And my C prime would be 4, -2. All right, I'm going to use pencil to move those on the graph. Something to keep in mind, sometimes this is a little bit of trial and error. So you might try something and then be like, ooh, that was not good. That's okay. That's the whole point of this, is to be able to kind of reason your way through it. You don't have to be perfect, 1, 2, 3, 4, on the first one. Right? You don't have to be perfect at all. You might come into class and be like, I tried it and I'm not really sure. And that's okay. All right. So let me get this connected here. All right. Now I've at least got it vertical. From there, I want to shift it up and get it to flip over. Now you might already be thinking, if I rotate, do I have to rotate about the origin? No, not necessarily. So you could have picked a different point to rotate about. I could have picked a different point to rotate about. I could have rotated about maybe point A itself or something different, right? So what I'm thinking is, if I can flip this thing over, now I've got it laying in the right direction. Then I would just need to shift it into the right spot. So when I say flip this thing over, I mean, let's reflect it. And because I'm going to have to shift it anyways, I'm going to reflect it just right over the y-axis. Now, any vertical line would do, all right? But if I flip it over the y-axis, each point will just hop right on over. So there would be like my B double prime there, and my A double prime would land over here. So remember, what's happening when you flip over the x or the y-axis? The y doesn't change at all right? The x simply changes sign. So instead of 1, it's now -1. Instead of 1 here, it's -1. This would be -4, -2. So let me get a second to plot that. So -1, 2, 3, 4, down 2. All right. So I've now moved my triangle so that it's flipped over here. Now I've got the orientation in the right spot. So that's looking a little bit better. I'll try to darken that up. I know it's a little tough to see on the video when I work in pencil. All right. And so now that we've got this guy here, now all we have to do is take each point and shift it over and then up. So when I say over and then up, I'm going left 1, 2, 3, 4, up 1, 2, 3, 4. And double check, make sure it works for all of them. So left 1, 2, 3, 4, up 1, 2, 3, 4. Heck yeah, it does. So that's a translation. Left 4, up 4 is -4, +4. All right, and what that should do, that should land me on my final points of Q, R, and S. All right, so let's describe it. If we describe it in words this time, then what we're looking at would be a rotation 90 degrees about the origin, because you do have to specify. Now, if I use my notation and you don't say anything else, it's assumed the origin. Otherwise, you have to say about the origin, followed by a reflection over the y-axis And then finally, a translation left, 4, and up 4 units. All right. If we were to write this notation-wise, make sure rotation of 90 followed by a reflection over the y-axis, followed by a translation left 4, up 4. That's kind of crazy looking, but that is what it would look like. All right. I'm thinking maybe let's do 1 or 2 more, and then we'll save the rest to do some practice in class. With that being said, this bottom one here, you got trapezoid ABCD. It's going to land on A prime, A double prime, B double prime, C double prime. So sometimes it makes it easier when they label it that way, so you can see exactly which point goes to which. Because this is not going to match to here. A has to come over here. So not only do I need to kind of get this trapezoid to flip upside down, I also need to get it to flip over a little bit. So with that being said, this could be a combination of rotation and then you shift it, or we could do a little bit of a double reflection here. You could even do some double reflections and a translation. So there's so many options. That's the great thing, and that's also the tricky thing, so that if you're doing it on your own and you see something different than I see right now, don't let that throw you. Write down your question, ask it in class, all right? So in this case, I'm going to go with the reflection since we've already done some rotations here. So the line that I'm going to reflect it over so that I can get it to land directly on top of this. Well, let's figure out how far apart they are. So from A down to B double prime is 1, 2, 3, 4, 5, 6. All right. So right now, I can either flip it over this way first and then this way, which actually, yeah, maybe let's do that. Let's reflect it first. Right over the y-axis. That's going to get A to land over here at B and B to land over at A. So it's literally going to have things switch spots completely. All right. So if we do that, I'm going to have A prime here. This would be D prime. This is C prime. This is B prime. It'll land directly on top of itself because that line is cutting straight through it. All right. Then from here, now to get A to A double prime, we said that distance was 6, I believe. If we find the halfway point and flip it, then it'll land exactly on itself. So if it's a total distance of 6, if I come down 3, so 1, 2, 3, I'd want it to flip over here. Same thing, 1, 2, 3. So instead of using like the x-axis or the y-axis, I'm going to use this horizontal line. I'll highlight it in red so that you can see it better. Right here, the line y equals, it would cross at -1. So I'm going to reflect over the y-axis and then followed by a reflection over the line y equals -1, right? Notation-wise, if I put that all together, then I would be taking trapezoid A, B, C, D. I'd reflect it over the y-axis and then followed by a reflection over the line y equals -1. So I can write it like this, or I can write it like that. Right? And then what would happen? This point would land here. This would land all the way down here. C prime all the way down there. B prime all the way down there. Cool. All right. When we get to this next page here, I'm thinking let's hold on to some of these. Oops, my papers are stuck together. Let's hold on to some of these to go over in class. And what I'm thinking is I would like you guys to try one of them, but maybe I'll have you try one of the multiple choice. So all the way at the end of the notes here, number 8, it says identify the sequence of rigid motions. And this one's kind of helpful in that it tells you it goes from ABC to A prime, B prime, C prime, and then to A double prime, B double prime, C double prime. So by them giving you kind of the triangle in between, it should make it easier to answer. So with that being said, number 8, we're going to make that the post video question. And then 5, 6, and 7, we're going to save these guys for a little recap in class. All right. So 5, 6, and 7, hold on to those. Number 8, go try that right now and answer it as the post video question. Thanks guys for watching.